All right. So in this screencast, we're going to talk about Unit 5 in Living by Chemistry, which is entitled Fire. And the hook to this unit, to make it engaging for students, is basically asking them to explain what is fire. And they will explain it through the chemical reactions perspective, they will explain it through the thermodynamics perspective, and they will examine some redox reactions and other things that maybe they don't initially consider when they think about fire through this unit. So in this screencast, I'm going to give you an overview of the fire unit, and we're going to pay careful attention to the recommended order listed in the pacing guide. For most units, it is basically to follow the sequence presented in the curriculum. Boston recommends very specific changes to fire in terms of the order in which it's presented in order for essential content to be covered throughout the school year. I'll talk about 2 difficult lessons and provide you with some resources. So, the recommended lesson sequence, and I will refer to the pacing guide in just a second, is to do a fire supplement after the first section of toxins. Okay, so we're talking January into February at that point, and then to finish the toxins unit, do the weather unit, and then to do a second fire supplement following that. So the first supplement is especially diverging from the sequence in the curriculum, in that students will first learn about combustion from lesson 7, then they will move on to lessons 15 and 17, which teach about oxidation reduction, and then moving back to the first 3 lessons of the curriculum, which are all about heat flow. Following that, they will do lesson 13, which is basically a standalone lesson which talks about factors which enhance the rate of reaction, some simple kinetics. So it's going to be very important to spend a lot of time critically reviewing the teacher's edition and what students would learn in lesson 5 and how that leads into lesson 6 and what then the curriculum presumes that students would understand in lesson 7. So it's going to be especially important to pay attention to contextualizing these lessons as they will be out of sequence. The second supplement is most of the lessons between lesson 10 through 19. That would be a little less difficult to contextualize as the result of them basically all being in order. So to take a little bit of a closer look, all right, so this is the pacing guide. And we see that the fire first supplement involves first lesson 7, okay, where students learn about combustion reactions, then metal magic and electron cravings, lessons 15 and 17 respectively, where students are learning about oxidation reduction. And then we go back to those first 3 lessons of the unit where students are learning about drawing heat arrows to show the direction of heat flow in endothermic and exothermic reactions. And they will be missing then some content which talks about things like heat of fusion for water, and topics which are less heavily represented in the standards and therefore have been eliminated in the interest of time. So we go through the toxins unit, we go through the weather unit, and then we have fire supplement 2, which is lessons 10, 11, 12, and then 14 through 19. All right, so in order to talk about a couple of difficult lessons, the 2 that I think would be most worthy of giving some extra treatment to would be lesson 7, first of all. Lesson 7 involves students exploring several combustion reactions. And while we want to trust our students to be safe, a huge number of combustion reactions laid out for students, to me, would give me pause. And at this point in the year, I would feel very comfortable with my students and knowing their behavior in the lab and everything like that. But it would just concern me with all of the unique hazards presented with combustion reactions to have the students actually carrying all of these out. For example, we see a picture here of the combustion of magnesium, very, very intense. bombarding your eyes with a lot of photons over a very short period of time. When my students are observing the combustion of magnesium, which I think is important because it's a very dramatic example of combustion of a non-organic compound, we're seeing the oxidation, which is showing us a glow, but no flame, so to speak. And that teaches us a lot about what's going on the surface. But I want the whole class to be very clearly instructed not to look directly at it, and I want it to be far away from many students. So I want to do that as a demo. Additionally, the combustion of hydrogen is part of this lesson, and if it's going to be done, it shouldn't be as large as in this demonstration, which is clearly someone who's doing it at a show, and it should be behind a demonstration shield. Even a small balloon that is combusted with a small amount of hydrogen, perhaps the hydrogen combusting isn't a concern, but hot pieces of plastic could accompany that. So if you are to do the combustion of hydrogen in front of students, a demonstration shield is highly, highly recommended for their safety, because their safety is your utmost and primary concern anytime that's going on. So I would recommend doing lesson 7 as a series of demonstrations, and to be very cautious about certain combustions, and to definitely use a demonstration shield. The other challenging lesson is lesson 12, Over the Hill. And I'm going to be honest, as someone who has taught chemistry for over 12 years, I have a very hard time making an electrolysis setup which shows a great ratio of 2-to-1 moles of hydrogen to oxygen. There's a lot of energy loss, and various setups I've had struggle with. However, I think an excellent setup is in this diagram here, where you have a plastic cup with 2 holes punctured in the bottom of it for thumbtacks, and they're spaced out the perfect distance between the positive and negative electrodes of a 9-volt battery. Pop 2 test tubes over that, which are filled with water, and this will happen relatively quickly. It can be supported by a ring stand, and will work very well to show you the 2-to-1 ratio of hydrogen to oxygen gas in the test tubes. And then you can show the classic pop of the hydrogen in that test tube combusting, and you can see the flame lighting up more brightly, but no combustion in the oxygen test tube. All right, so I would recommend using this setup in order to do electrolysis rather than that one suggested in the teacher's edition of the FIRE curriculum. And I have a link to set up for this easy and successful electrolysis device in the future slide. So that slide has now come into being. Supplemental lessons and animations. I have a lot of resources on my website. You can access it through this link. Pacing guide, as I've mentioned, is especially important for the way that Boston recommends to teach essential content in the FIRE unit. That can be reached at the BPS Science Weebly website. And below is a link to a 2.5 or so minute video of the electrolysis setup using the 9-volt battery and thumbtacks and a plastic cup. Super easy, super effective way to show electrolysis. As always, if you have any questions about teaching chemistry to your classes using the Living by Chemistry curriculum, you can contact Pam Pelletier, Holly Rosa, or myself via our email addresses here with any questions or concerns.